for free. After we add a speak method, our cat can both breathe and speak. There will be situations where certain properties of the superclass should not be inherited by a particular subclass. Thought birds generally know how to fly. Penguins are flightless subclass of bird. In the example bird.rb below, we override fly in class penguin. Let's see the example. Class bird, deaf brain, put I am cleaning my feathers, and deaf fly, put I am flying and n. In the 10th line, class penguin inherits the bird class. Deaf fly, put sorry, I rather swim, and n. So we are taking a variable as a p and creating object penguin.new. We calling the methods of preen and fly. So let's see the output. I'm cleaning my feathers. Sorry, I'd rather swim. Rather than exclusively define every characteristics of every new class, we need only to append or to redefine the difference between each subclass and its superclass. This use of inheritance is sometimes called differential programming. It is one of the benefits of object-oriented programming. Thus, inheritance allows you to create a class that is refinement or specialization of another class. Inheritance is indicated with less than sign. A class can only inherit from one class at a time. Example, a class can inherit from a class that inherits from another class which inherits from another class. But a single class cannot inherit from many classes at once. Polymorphism. The ability to have different classes containing methods with the same name goes by the fancy object-oriented name of polymorphism, a term which once remembered can safely be forgotten when you run a program such as 6dogs.rb. The code is executed in sequence. Okay, let's see the code. Class dog, set def set name, a name, at my name equals a name, and def get name, return at my name, and def dog, return woof, and end. Oh, let's go to the cat class. The class cat, def set name, a name, at my name equals a name, and def get name, return at my name, and def dog, return meow, and end. Okay, let's create instance objects of the dog and cat class. My dog equals dog.new. Your dog equals dog.new. My cat equals cat.new. Your cat equals cat.new. Some other dog equals dog.new. Okay, let's name them. My dog.setName Fido. Your dog.setName Bonzo. My cat.setName Tiddles. Your cat.setName Flossie. Okay, now we'll get their names and display them. First of all, we'll get the names of dogs. Puts my dog.getName. Puts your dog.getName. What happened here if the dog has no name? Puts some other dog.getName. Okay, let's get the names of cats. Puts my cat.getName. Puts your cat.getName. Then we'll ask them to talk. Puts my dog.talk. Puts your dog.talk. Puts my cat.talk. Puts your cat.talk. Okay, let's see the output. In here you get the Fido Bonzo, and you see there's a space because we haven't given name to some other dog. And the Tiddles and Flossie are there, the cat names, and woof woof, meow meow is the way each cat and dog speak. The code of the classes themselves is not executed until instance of those classes, example objects, are created by the code at the bottom of the program. You will see that I frequently mix class definitions with freestanding bits of code with execute. When the program is run, this may not be the way you would want to write a major application, but for just trying things out, it is extremely convenient. Now let's talk about the difference between Ruby and other language. First of all, we'll talk about Ruby against C. There are no header files, you just define your functions, usually referred to as methods, and classes in the main source code files. All variables lives on the heap. Further, you don't need to feed them yourself. The garbage collector takes care of that. There's no semicolons ending lines. There are no variable declaration. You just assign to new names on the fly when you need them. Okay, now let's see the Ruby against C++. Objects are strongly but dynamically typed. The runtime discovers at runtime if that method call actually works. All methods are always virtual. You don't directly access members, variables. All access to the public member variables, known in Ruby as attributes, is via methods. Now let's talk about Ruby against Java. You don't need to compile your code, you just run it directly. All member variables are private. From outside, you access everything via methods. Everything is an object, including numbers like 2 and 5. There is no casting, just call the methods. Let's see Ruby against PHP. Strings, numbers, arrays, hashes, etc. are objects. Parentheses are optional in method calls, except to clarify which parameters go to the which method calls. Reflection is an inherent capability of objects. You don't need to use reflection classes like in PHP 5. Now let's talk about Ruby against Python. There are no new style and old style classes, just one kind. You never directly access attributes. With Ruby, it's all method calls. You can add or modify the methods of built-in classes. Both languages let you open up and modify classes at any point, but Python prevents modification of built-ins. Ruby does not. Okay, now we have come to the end of this video section. We'll take a wrap up of what we have done in this video section. We have talked about the class, objects, methods, instant variables, encapsulation, inheritance, polymorphism, and then we have talked about the comparison Ruby with other languages. I hope you have got a clear idea about Ruby.